Hello students, welcome to Sreenath Academy. In this video, we are going to discuss the fifth chapter, which is Understanding Elementary Shapes from CBSE Class 6 Maths. Okay students, my name is Karthik Dune. We are creating videos on all chapters and all subjects from class 6 to class 12. So please do subscribe our channel. Also like and share our videos. Also follow on Instagram and join our Telegram channels. Without wasting time, let's begin this video. Okay students, what is our present chapter? Our present chapter is Understanding Elementary Shapes. So we're going to understand some elementary shapes. So this is our present chapter students. So we are going to discuss each concept in it, and we are going to do some example problems if any is there on this. We are going to discuss each topic detail. Okay students, in the beginning we are going to have the overview of the whole chapter. After that we will discuss each topic in detail. At the end we are going to have the summary of the whole chapter. That is our plan for today students. Okay, so in this chapter we are going to learn about the measuring line segments. We know what are line segments. We know what is the difference between the line segment and a line. So how we will measure the line segments? So why we need to measure the line segments and how we will measure the line segments most preciously. So that is the thing we are going to discuss now students. So after that we are going to discuss about the angles. So right angles and straight angles, about those things. And after that we are going to discuss about the acute angle, obtuse angle and reflex angles. Okay students. And after that we are going to discuss about the measuring angles. So how we will measure angles. After that we are going to discuss about the perpendicular lines. What are perpendicular lines? When we call two lines as perpendicular lines, what are the conditions for a lines to be perpendicular? So that condition we are going to learn now. And next thing is the classification of triangles. And after that we are going to discuss about quadrilaterals. And after that we are going to discuss about polygons. And the last and the most important thing is three-dimensional shapes. Until now we have discussed about two-dimensional shapes. Now we are going to discuss about three-dimensional shapes students. What are the three-dimensional shapes and what are the names we called in three-dimensional shape? That is our whole chapter students. That's it. This is the end of your chapter. So this is the whole chapter about understanding elementary shapes. So this is the whole chapter overview. Our overview of the whole chapter is completed now. Hello students, now we are going to discuss about the measuring line segments. In this video, how we will measure the line segments. What are line segments and what are the lines? Yeah, we are going to discuss. So basically line segment. So line segments are different from lines. I think you know the difference between them. Basically lines didn't have any endpoints. They are like we represent lines by two arrowheads at the both ends. There is no endpoints for lines, but for line segment we have endpoints, so it will not be extended. The two ends will not be extended, but in the case of lines the two ends will be goes on extending. So we can't measure how much it is. We can't measure. Why? Because it is always expanding, it is always extending, so we can't measure. But in the case of line segment, it has two endpoints, it is limited, so we can measure line segments. So okay, we know line segments and we know what is the difference between line segments and lines, but how to measure it? So, or why to measure it? Why to measure means to show the difference between different line segments. That for that reason we want to measure it. Okay students, so basically you have some height and your parents have some height and your elder brothers have some height. So we will measure our heights or not? We will measure now. Whenever we went to the hospital, what will we do? First initially what they will do, they will ask for your name and they will ask for your age also. Why to measure your age? Why to measure yours? And they will ask about your height and your weight also. They will, even though if you don't know your weight, they will measure also. Why? Why? Because means we need every measurement, length, suppose your age, suppose your weight, suppose your height, to know the difference between others, to differentiate. So in the same way, we have to know, or we have to measure line segments to differentiate from other line segments. If you know the measure of a particular line segment, then we can simply differentiate from other line segments. Otherwise, all line segments will like a crowd of people. We can't differentiate them. So we need to measure the line segments. So we need to measure line segments. In addition to it, we also need to measure angles. In addition to it, we also need measure everything. So basically, we are measuring our height, we are measuring our age, we are measuring our weight. Why? Because means it is needed to know, to differentiate. So that's why we have to measure everything. Okay, students. So related to it, here we are measuring the line segments also. After that, we are measuring the angles also. That's it, students. That is the purpose of measuring. Okay, students. Now line segments is there. So how to measure line segments? So basically there is three methods. So basically how we will measure line segments is there are three methods. This measure of each line segment is a unique number called its length. So how we will represent the measurement of a line segment? How will measurement of line segment is length, students. Length is length. So you will measure your height in terms of how many meters are you. You will measure your weight, how many kilograms of weight are you. So you will measure your age, how many years are you. So like that we are measuring the line segments. So how we are measuring means how much length it is. How much length it is your line segment. So we will measure the we will call that measurement as a length. Okay, students. So what are we are having some methods to measure the length of a line segment. Okay, students. First method is comparison by observations. So by comparing two line segments, that comparison is to measure now. That comparison by observation, by our eyes we are going to observe. So by our observation we can measure or we can compare which line segment. Suppose if we are having two line segments, which line segment is more having more length, or which line segment is bigger or longer. So if you see AB and CD, which is longer, which line segment is longer? Obviously AB is longer. So by our eyes, by our observation, we can simply judge, or we can simply say that among these two line segments, AB is greater or AB is longer. So now again I will ask you a question. So just observe these two lines. Among these two lines, which one is longer? So now it takes some time to tell your answer, to judge. Why? Because means they are having approximately same length. So that's why sometimes whenever they are having approximately same length, it's become difficult to differentiate, or to become difficult to compare. So the method of comparison two line segments by our observations, by using our eyes, is not correct method. Why? Because means if there is a considerable difference between two line segments, we can easily judge which is longer or which is shorter. But whenever they are having approximately same length, we can't judge easily. It takes some time, it is somewhat difficult, it will have some errors. So this method is not good. So we have to improve our comparison methods. Okay, students. So in this case, PQ and AB, of course these two are having same length, but with our observation using our eyes, we can't say that both are equal. So that is the problem with our eyes or with our observations. So comparison by our observations is somewhat not good method. So we have to opt for another method. So next method is comparison by tracing. Previous method is comparison by observation. In this method only we have said that AB is longer. Next thing is tracing. So using tracing, so how we will trace means basically there are two line segments AB and CD. So to compare AB and CD, to compare two line segments AB and CD, what we have to do, we have to use a trace paper and we have to trace CD and place the CD on AB line segment. So by tracing the CD on AB, we can compare which is longer. So but every time doing this somewhat difficult and we get many errors. So if you want to compare with these two line segments with another line segments, what you have to do, again you have to trace and again you have to draw. So this is always some lengthy process, complex process. So this will also not give the good results. So we have to search for another method. What is the search another method? Comparison using ruler and divider. Here by the use of ruler and divider we can compare. So basically we know this is our ruler. So one side it has 15 parts, 15. So on the scale like this 1 2 like this, it will have 15 here at the end, 15. So 15 parts are there. So the gap between each part we called it is, suppose it is here, from here we called it as the 1 centimeter length. Okay students, here the gap between these two is 1 centimeter, these two is 1 centimeter, these two is 1 centimeter. So from this 0 to this point 3, how many centimeters? From this to this there are 3 centimeters. Like that this ruler will helps to compare or measure. Okay students, so one side it has 15 equal parts, each equal part is 1 centimeter width. Okay students, by using it we can measure. Suppose if you want to measure a line segment, that is AB, what we have to do, we have to place the ruler at that line segment. And how we have to place it is, one end of the line segment is placed at the 0, one end. So one end is placed at the, suppose A, that one end is placed at the 0 of the ruler, and after that another end will be close to any other reading or any other part on the ruler. So by observing the coincidence of the another end, which is B of the line segment, with the markings on the ruler, we can find how much length it is. Suppose that another end of the line segment B is coinciding with the 3 on the ruler, then we can say that this length of the line segment is simply 3 centimeters. Sir, how did you know, sir? How did you know is basically that A point, one end is at the 0 of the ruler and the another end is at the 3 of the ruler. So the distance or the length from 0 to 3 is 3 centimeters. So the AB line segment distance or the length is also 3 centimeters. So in this way, by using ruler, we can measure the length. So basically in the ruler, what happened, there is 0 1 2 3 like that and so on, 15. There are 15 equal parts are there. We called equal part as the 1 centimeter, and in the gap of 1 centimeter you observe from 0 to 1 there will be another 10 subdivisions. How many subdivisions? Another 10 equal parts in between 0 and 1. So what are those equal parts? So each equal part is equal to 1 mm. What is mm? Students? Mm is equal to millimeter. What is cm? cm is centimeter, no? Cm is centimeter. So in a scale, there are 15 equal parts. So we called each length of or length or the so each part as the 1 centimeter, 1 centimeter. So 15 equal parts. Okay, students. Each equal part equal to 1 centimeter. What is centimeter? Cm. Cm is centimeter. So, and what is the comparison between centimeter and millimeter, students? We know that is 1 centimeter equal to 10 millimeters. 1 centimeter equal to 10 millimeters, students. So, this is all about the ruler and the markings and the readings on the ruler, students. Okay, so by the time of seeing this, watching this video, just take your ruler and observe it, and again watch this video, then you can easily understand it, students. Okay, now, okay, students, so but by measuring with the ruler also there are some errors, no, students. Basically, the thickness of the ruler may cause difficulties in reading of the marks on it. So what are the difficulties? Means the thickness of the ruler is somewhat gives some troubles. So, and one more error is the positioning error. What is positioning error means? So if you want to observe careful observation or correct reading, your eye is always must be perpendicular to the ruler. Suppose if you are seeing from making some certain angle or from one side of the ruler like this, you will get some error, or from another side also you will get some error. But only whenever you are seeing perpendicular, which means straight onto the ruler only, then you will get the correct answer. So those are the difficulties, errors while seeing the measurements, measuring the line segments in the case of using ruler, students. Now we will observe, or we will use another thing, that is divider. What is divider? We know this is the divider. Okay, students, it has two arms or two legs, whatever you call it as. So using this also, you can measure the length of line segment. Suppose the line segment is AB is like that. So what we have to do? We have to stretch or elongate the two ends or the two arms of the divider and place the two sharp points of the divider on the line segment AB like this, students. So one arm of the divider sharp edge at one end of the line segment, and another arm of the divider at another dot of the line segment. So, and after doing this, without disturbing the angle between them or without disturbing this divider, just take this and place it on the ruler, and one end you have to place it at the 0 of the ruler, and the another end will coincide with some value on the ruler, and that some value will give rise the length of the line segments. So that will give the length of line segment. So in this way, by using divider, you can find or you can measure the length of line segment, friends. So this is the best thing you can do. So that's it, friends. So in this way, you have to measure the length of line segments. Hello friends, in this video we are going to discuss the angles, right angles and straight angles. And next thing we are going to discuss about the acute angle, obtuse angle and reflex angle, students. After that we are going to discuss about the measuring angles, how to measure the angles, what is the measure for it, and discuss about the protector. And after that we are going to discuss about the perpendicular lines. What are perpendicular lines? When we say that two lines are perpendicular, so all these we are going to discuss now, students. So basically what is our discussion, where our discussion is going to be started is that is angle. So in the previous topic or the previous video, we have discussed about line segments, how to measure line segments. The measure of a line segment is a length. So here we are going to discuss about the angles and how to measure angles. So basically we know we are going to discuss about angle, students. So in the geography or in the case of directions, we have learned something, that is China. So China is north to India and Sri Lanka is south to India, like that we have discussed. And we know that sun rises in the east and sun sets in the west. So basically we know that about the directions. We know about the directions. Suppose this is the north. Suppose if this is the north, the opposite to the north direction is south direction, and this will be the east direction, and the opposite to the east direction will be west direction. The sun rises in the east and sun sets in the west, we know. And for the case of India, I'm not good at drawing skills, students. I can't draw the map of India. So for India, on the north there is China, and there is south there is Sri Lanka. Now Sri Lanka. So this is all about what? Directions. We know about directions. Okay, students, this is in the geography, all that. So now we are not going to study about the directions, not about the geography, students. Don't worry about it. We're just going to study about the angles, how to measure it, and what are the angles. Suppose if you are standing at this point and you are facing towards north. Okay, students, and you are facing towards north. So when you are turning towards the east direction, by a right angled turn towards the east direction. Okay, students, towards east direction in the clockwise direction. Clockwise direction means, so this is the clock now. This is the hands in the clock now. How they will move? They will move in this direction. Okay, they will move like this. They will not move like this. So if there is a clock in your house, if you see at this is the hands, this is the hour's hand. After some time it will there. So it has moved this direction, but it does not move this direction. If you just see the hour's hand is at this point, if some after X time it not will be there this direction, it will not move in this direction, it will move in this direction, like this. So we call this as the clockwise direction. What it is? Clockwise. And we call this as the anti-clockwise direction. What it is? Anti-clockwise direction. Anti-clockwise direction. So if we show that it is moving this side, we call it as the clockwise. If you say that it is moving this side, if you say it is moving this side, we say it is anti-clockwise. So you have to understand what is clockwise and what is anti-clockwise, students. So after that, where you are facing towards north, you have turned towards the east. So in the clockwise direction. So now we are facing towards the east. So now we say you have turned towards a right angle. What is right angle? Now you have turned a right angle. How much angle you have turned means it is a right angle. Suppose a right angle. Suppose again now you are facing towards east and again you have turned in the same direction through another right angle. Then you will get the south facing. So how it is the south facing? It is basically opposite to the north facing. Basically in the first you are facing towards the north direction. Now you are facing towards the south direction. It is quite opposite. So we call this entire turn from north direction to south direction as this is like a straight line. No, so we call it as a straight angle. What it is? Straight angle. So we can say that two right angles is a one straight angle. If you want to get one straight angle, you have to move two right angles. That's it. No. So now suppose if you have to move again another straight angle in the same direction, what is your final position? Obviously your final position will be your original position, that is towards the north. Why? Because means if you want to move a straight angle, you have to move two right angles. So for one right angle you will get towards the west, and for another right angle you will again get in towards the north. So this is about the total straight angle. So So this is all about in the clockwise direction, students. Okay, so finally so suppose this is the north and this is the south. You have turned all about these two right angles. We say that it is the straight angle. What it is? Straight angle. Suppose you have turned from north to east, we say that it is right angled. Right angle. This is right angle, students. So this is the difference between right angle and right angle, straight angle, students. Suppose if you have moved north, south, we have moved one straight angle and again we have moved another straight angle. So finally you will say you have reached your original position now. You have reached your original position now. So we call it as the complete angle. What is complete angle? Complete angle. Why? Because means you have completed one revolution, which means you have reached the final position. Your final position is nothing but your original position. So after making terms, you have reached your original position. So which means you have completed one revolution. So this is called as complete angle. Okay, students. So this is the difference between the right angle, straight angle, and complete angle. So if you see, whenever if there is our hand is at 12 and after some time after 12 hours it will again comes back to the 12. So which means it has completed how much? It has completed one complete angle. Complete angle. Suppose whenever the hour's hand is at 12, it has reached the position point, sorry, the number 6. So we say that it is how much? That it is a straight angle. That is the straight, which means the original position is quite opposite to the final position. So that it is the straight angle, one straight angle, or two right angles, or two right angles, one straight angle, or two right angles, or 1/2 of 1/2. Here it is there now 1/2 of revolution. So it is the half of the revolution. Okay, students. Suppose if the hour's hand is at 6 and it has moved to 9, what we call it as? It is called as the right angle. It is there one right angle, or 1/4 of a revolution. So 1/4 of a revolution, or 1/2 of a straight angle also we can say. Suppose if it is like that, the angle from 1 to 10, what we called it as? So basically it is at 1 and after that it has moved and it comes to 10. So basically in between 10 to 1 there is right angle now. But we want the angle between these two lines in this direction, not in the clockwise, not in the anti-clockwise direction, in the clockwise direction. Clockwise direction is you have to see in this direction. So in this direction it has moved almost 3/4 of a revolution, or 3 right angles. It has moved 3 right angles, students. So it has moved 3 right angles, or 3/4 of a revolution. Revolution means one complete one revolution means one complete movement, one complete angle, or one complete revolution. So here basically it is 3/4 of a revolution. Okay, students. So this is about the right angle, straight angle, and complete angle. So right angle is basically by 90 degrees. We will see about degrees and 90, and straight angle is about 180 degrees. We will see later about 180 degrees, and we will see 360 degrees as complete angle is 360 degrees. These three values will be discussed in the next upcoming topic, students. Okay. So after that we are going to discuss about acute, obtuse, and reflex angles. So what are obtuse, acute, and reflex angles? So basically what we have discussed is there are right angles, straight angles, and complete angle. But every angle need not be always right or straight or complete angle. In some cases there are angles other than right, straight, and obtuse angles. So right, straight, and complete angles. The example is here. Suppose there is a ladder which is like this. So the angle the ladder makes with the ground, or the angle that ladder makes with the wall, is not a right angle, is not a straight angle, is not a complete angle. So what does it angle we call as? So that the thing we are going to discuss now. So basically regarding about the right angles. So the English letter L, it alphabet, it is a example for right angle. No, so it the two line segments are to L alphabet having 90 degrees, which means it is showing the 90 degrees or the right angle. And you may see that carpenter square is like that. Carpenter uses this square to find the perfect right angle edges. So it is also like a right angle. So now we can make our own tester to test whether the angle is a right angle or not. We can do it by ourselves. So with the help of the carpenter's tester also, you can find that the angle is right angle is not. But if you have that carpenter's tester, you can use it. But if you don't have it, no problem, we can make our own right angle tester. That is, we call it as RA tester. So take a piece of paper and fold it like that. So after folding it like that, again fold it like that. So finally these two edges, so these two edges, so the angle between these two lines or these two foldings, so if the two line segments are like this along the edges of this paper, then we say that the angle between those is right angle. Okay students, so this is our own RA tester, and now using it we can test some of the angles, students. Suppose just the angle between the 12 and 5, what it is, if you place your RA tester here, it will shows it is above the right angle. If you place it here between 5 and 7, here the angle, so it will shows that angle here is below the or less than the right angle. So finally what is our conclusion is, there are some angles which are greater than right angle, there are some angles which are less than right angle. So what we call as those angles, so we have differentiated them into three groups. So one is acute angle. Acute angle means what? So angle less than right angle, angle less than right angle. So any angle which is less than right angle, we call it as the acute angle, students. So next thing is what? That is obtuse angle. What it is? Obtuse angle. So what is obtuse angle? Is any angle or angle, what we call it as, it's nothing any matter, any angle which is greater than right angle, we call it as obtuse angle. What it is? Obtuse angle, students. Okay, that is, suppose what are the examples for acute angle? Suppose there is a rooftop. Now the angle between the two it is the acute angle. So, and if you open a book like this, okay students, if you open a book like this, is the book, and if you open it like this, so the angle between the two these two, the angle between this and this, it is the acute angle, So basically this is the right angle now. So the angle less than the right angle is acute angle. If you want the obtuse angle, so the book has to be opened like this. So this is the obtuse angle. Why? Because it is greater than the right angle. Right angle is here, so it is greater than right angle. Right angle is here, it is less than the right angle, so it is acute angle, students. So that is about the acute angle and obtuse angle, students. Okay. So book reading desk, it has a obtuse angle. Okay students, so this is about the obtuse angle, students. Okay, and what about a reflex angle? So what about reflex angle? So reflex angle is a angle greater than right angle. What it is? Until now we have used the right angle. Suppose if it is greater than the straight angle, not the line, right angle, we call it as the reflex angle, students. Okay, suppose what is the straight angle for it? So this is the straight angle for the book, students. Suppose if the angle is, if you are measuring from this side to this side, and suppose if the angle is like this, so it is reflex angle. Why? Because this is the straight angle, it is greater than the straight angle, so we call it as the reflex angle. So if you see these two heads, suppose if it is like that, then the angle between these two is straight angle, but it is greater than the straight angle now, so that angle we call it as the reflex angle, students. So this is about the reflex angle, obtuse angle, and acute angle, students. Okay, so we have understand what right angle, what straight angle, what complete angle, and what acute angle, what obtuse angle, and what reflex angle. So you may think that we have gained so much of knowledge, so we have learned all about the angles, but that is not the truth, students. So we can guess, or we can say whether the angle is a right angle or the straight angle or an acute angle or an obtuse angle, but not you completely or more preciously, more accurately you can't tell what the angle it is. So for that we need further more improvement, further more helpful things, or further more crystal clear, more precious, or more not precious, more precise measurement for angles. So the measure of angles is degree measure. What it is? Degree measure, students. Okay, so basically measure of the angle is degree measure, students. So basically one complete angle, what it is, or complete revolution, one complete revolution is divided into 360 equal parts, and each part is how much? Each part is 1 degree. So therefore for complete angle, how many degrees it is there? What is the total measure for complete angle? There will be 360 equal parts. No, one part is 1 degree, so 360 parts is 360 degrees. So we represent degrees by a small zero in the upper side like this. So for a right angle, how many degrees? Suppose for complete angle it is 360 degrees. Then for a straight angle, how much it is? So basically 2 straight angles is 1 complete angle. So for one straight angle it is about 180 degrees. Why? Because means 360 by 2, no? So for right angle, how many degrees? For right angle it is about 90 degrees. Why? Because means 360 degrees by 4, no? We know one complete angle is 360 degrees, and we know one straight angle is a 1 by 2 of complete angle, and one right angle is 1 by 4 of complete angle. For that reason this is about the 90 degrees, 180 degrees, 360 degrees, students. Okay, so to measure more perfectly we need an instrument called as to measure more perfectly the angles, we need instrument called as protractor. What it is? Protractor. So it will be used to measure the angles more preciously, students. So we can make your own protractor also. For that using your bangle or that, draw a circular shape and cut it and fold it along this. So it will be looks like a what? So the angle here is 360 degrees, and if you fold it like that, so it will becomes the semicircle. So the angle between these two, this is the straight angle, and this is the whole complete angle 360 degrees. Now again what you have to do after, if it will looks like that, so after again along this fold you have to again fold it, so it will looks like, though again the angle here is 90 degrees. Okay, students, so basically the angle between this and this is 90 degrees, no? So for the angle between this and this is the 90 degrees, and the angle between this and this is 180 degrees, and the angle between, so it is like that, no? The angle between this is 90 degrees, this is 180 degrees, this is 360 degrees, like that, students. So again what you have to do is, again you have to do some more folding. So again this right angle is again folded along this line, so then you will get like this, no? So if you draw that line, so that will gives rise the 45 degrees. If you consider it in the semicircle, so then it will becomes 45 degrees, it will becomes 45 degrees, it will becomes 90 degrees, it will becomes 180 degrees. So there this similar to this there is also another line at this point also. So basically from here to here, this small part is 45 degrees, so this small part is also 45 degrees. So from this point to this point is 90 degrees, this point to this point is 45 degrees, so 90 plus 45, that is equal to 135 degrees, students. So starting measuring from this point it is 135 degrees, so here it is 135 degrees written. So we can further fold this 45 degrees further, so you will get 45 by 2, that is 22.5 degrees. So that's why this is the 42.5 by 2 is 20.5 degrees. And again, if here also, if you again fold this, you will get again 135 degrees plus 22.5 degrees. So that will give rise to 157.5 degrees. So starting from here, that point, this line is at 159.57 degrees, students. So by using this type of measurement, you can clearly measure the angles. You can clearly measure the preciously. You can measure the angles. So you can use the ready-made device, that is nothing but protractor. So protractor is like that. It is like a semicircle. So it has readings from 0 to 180 degrees and from both ends. So if you see here, it is there is 0 now. So starting from 0, it has degrees up to 180 degrees. Even though if you start measuring from here, it will also 0 to 180 degrees. Why two readings means, suppose if you are measuring the clockwise direction, anti-clockwise direction, so this is the starting point 0, like that you will measure in this direction. Suppose if you are measuring in the clockwise direction, then you will start at this point, so then it will 0 will be like that, no, so you have to measure in like that. So for two measurements, it has two readings, students. Okay, so by using protractor, how to measure an angle between two line segments or two corners or two faces. Suppose the two line segments or anything is like that. First thing is, you have to if you want to measure the angle at B, then you have to place the protractor, midpoint of the protractor, that is M, at the coincides with the B, and you have to place the BC along the length of the protractor like that. So from, if you want to measure it in the acute in the anti-clockwise direction, if you want to measure the angle between these two lines, you have to start 0 readings here. You have to coincide with the you have to coincide this line with the 0 of the protractor, and starting from here you have to observe for another line, so which may be bisects or passing through any of the degrees. So basically here it is passing through the 40 number. So the angle between these two lines is 40 degrees. Suppose it is going to this, it is having 70, then the angle is 70 degrees. So simply by using the protractor, you can easily measure the angles, students. Okay, students, in this way you can measure the angles. So next thing is about, students, perpendicular lines. So what are perpendicular lines, students? So we know what are lines, and we know what are line segments, and we know what is the angle between the line segments, how to measure the angle between the line segments. If angle between the two line segments is 90 degrees, two line segments is 90 degrees, then we say then both line segments are perpendicular, or if the angle between two lines is also perpendicular 90 degrees, then we say that it has the perpendicular line, students. Suppose AB is a line segment and there is a midpoint called M. If there is another line which is passing through the midpoint line, which is passing the line segment of the AB, so we called that as the perpendicular bisector. What it is? Perpendicular bisector. Why we called it as the perpendicular bisector, students? Basically this line, what it is making 90 degrees angle with the line segment, so it is perpendicular. Next thing is bisector. So basically this line is bisecting or the cutting or bisecting the line segment, and it is bisecting at the midpoint. What it is? Midpoint. So for that we called it the bisector, perpendicular bisector. So whenever any line is bisecting at the midpoint and it is perpendicular to it, we call that as the perpendicular bisector of this line segment AB, students. So this is about the perpendicular bisector and the perpendicular line. Simply whenever the angle between two is 90 degrees or the right angle, those two lines are perpendicular lines. Suppose if a line is bisecting a line segment at midpoint, we call that as the perpendicular bisector, students. That's it, students. That is about the angles: obtuse angle, acute angle, right angle, straight angle, perpendicular lines, how to measure the angle. So that is, students, we have discussed all these concepts. Hello, students. Now we are going to discuss about classification of triangles, and after that we are going to discuss about the quadrilaterals. Okay, students. And after that, we are going to discuss about the polygons, and later and final thing is about the three-dimensional shapes. So these are the topics or the concepts we are going to discuss now, students. Okay, students. Yeah, what it is, the first thing is about classification of triangles, about triangles, students. So what we have learned until now is line segments, how to measure line segments, angles, how to measure angles, and what are the different types of angles, right angle, obtuse angle, straight angle, acute angle, like that, all the stuff we have discussed. So now we are entering into the topic called triangles, classification of triangles. So we know triangle is formed by three line segments. Okay, and in triangle there are three angles. So whenever there are angles, that angles may be acute or obtuse or right angle, like that. So now see these figures. So these are the examples of triangles. Okay, students. So these are the sides and these are the angles. So in a triangle there will be three angles, 1, 2, 3, like that. Okay, students. So these are the different types of angles. So so what is the thing is, if all the angles in a triangle are equal, then its sides are also equal. What it is, students? So if in a triangle all the sides are equal, what happened here? So basically here, if the angles are equal, then sides are also equal, students. So in a triangles in which all the three sides are equal. So triangles in which all three sides are equal. Suppose if sides are equal in a triangle, all the sides are equal in a triangle, then obviously angles also equal, students. That is the thing you have to remember. So in triangles which have two equal angles and two equal sides, suppose if there is a triangle in each, what happens? Two equal angles and two equal sides. So in this case, what happened? Triangle which, if two sides of a triangle are equal, it has dash equal angles. So if two sides are equal, then it has two equal angles. At the same time, if two equal angles are there, then two equal sides, it has two equal sides, friends. So triangles in which no two sides are equal, if none of the angles of a triangle, so there is another triangle, if none of the angles are equal, then what happened in this case? None of the sides will not be equal. None of the sides will be equal. So finally, the students, you can remove all the stuff what I have discussed just about these things, students. So just remember three things. So triangle, we know the triangle. So what happens? Triangle has three sides and three angles. So there are three types of triangles. What are those triangles? One is scalene triangle. Another thing is isosceles triangle. Another thing is equilateral triangle. So three sides, three angles, three types of triangles. Equilateral triangle, students. Okay. So when we call a triangle as a scalene triangle, so if it have three unequal sides, three sides are unequal, then we say the triangle is scalene triangle. So when we say that is isosceles triangle, suppose if it is having two equal sides, then we say that as a isosceles triangle. So when we say it is an equilateral triangle, suppose if it has three equal sides, or all the sides are equal, then we say that it is an equilateral triangle, students. Okay. So this classification is based on sides or line segments. Now based on angles. So triangles. how many types of triangles? So triangle has three angles now. So three types of triangles. One, it is acute angled triangle. Acute angled triangle. Another thing is right angled triangle. Another thing is obtuse angle triangle. What it is, students? Obtuse angle triangle. So these are the three types of triangles based on the classification is based on the angles. Suppose if the angle, if each angle less than 90 degrees, each angle is less than 90 degrees, we say the triangle is acute angle triangle. Suppose any one angle is equal to 90 degrees. In a triangle, there are three angles. If any one of the three angles is equal to 90 degrees, we say that it is a right angle triangle. In a triangle, there are three angles. If each angle, every angle is less than 90 degrees, we say that it is acute angle triangle. Suppose what is obtuse angle triangle? Basically, there are three angles. If any one of the three angles is having any one angle is greater than 90 degrees, we say that it has the obtuse angle triangle, students. Okay, so this is the acute angle triangle, or all angles are less than 90 degrees. So this is the right angle triangle. Here the angle is one angle that is 90 degrees. Here this is the obtuse angle. Why? Because here the one angle it is greater than 90 degrees, students. So this is the classification. So this is the classification of triangles based on the sides and based on the angle, students. So previously what it is there means, suppose if all angles are equal, then sides are also equal. If all sides are equal, then all angles are equal. Suppose if two angles are equal, then two sides are equal. Suppose if two sides are equal, then two angles are equal. If suppose none of the angles are equal, then none of the sides will not be equal. Like that, students. So this is the relation about the relation between the angles and sides. So based on the sides, we have classified triangles, and based on the angles, we have classified triangles, students. Okay, that is all about the triangles, students. So we have completed our discussion about triangles. Now we will discuss about the quadrilaterals. We know that triangles and quadrilaterals all comes under the polygons. So polygons are closed lines, closed figures, closed curves which are formed by line segments itself. So quadrilaterals. So quadrilateral is nothing but a polygon with four sides. Polygon with four sides, four line segments is called a quadrilateral. So this is our previous knowledge. So suppose take four unequal sticks and match them to form a quadrilateral like this. Okay, students, match them like this. So what happened? So you will get this quadrilateral. It has sides. What are the sides? AB is a side. Let us write the sides are what? Sides are AB is a side, BC is a side, CD is a side, DA is a side. So all are these are the sides. So what are the angles? It is having basically four angles. That is angle DAB and angle ABC and angle BCD and angle CDA. So all these are the four angles and the four sides. And there are the diagonals also. What are the diagonals? So diagonals are AC is a diagonal, BD is also another diagonal. So this is the quadrilateral. It has four sides, four angles, two diagonals. So on the lengths of the sides we called it so now what we have to do, just measure the lengths of the sides and observe whether all the lengths are equal or not, and measure the angles and observe whether all the angles are equal or not. Okay, students. So what happens if there is a quadrilateral? Can you imagine or can you guess? Can you draw a quadrilateral with all four angles acute, or one of the angle is obtuse, or one of the angle is right angle, or two of the angles as obtuse, or two of the angles are right angle, or the diagonals are perpendicular to each other? So in each case, just imagine or try to draw a quadrilateral with this condition. And with this condition, try to draw another quadrilateral. With this condition, try to draw another quadrilateral. Like that, using these conditions, try to draw different types of quadrilateral, students. So basically, what we know is Quadrilateral, it is a polygon with 4 sides. It has 4 sides and 4 angles and 2 diagonals. That's what we know about quadrilateral, students. So suppose if you have two set square, one is 30 degrees, 60 degrees, 90 degrees, and another is 45 degrees, 45 degrees, 90 degrees, two set square. If you pair, if you both of you will have a pair of 30 degrees, 60 degrees set square, place them as shown in figure. So suppose if you have pairs of these set squares, if you have two set squares like 30 degrees, 60 degrees, 90 degrees set square, if you match them like this, you will get a quadrilateral which is rectangle, using what 30 degrees, 60 degrees, 90 degrees set square. So if you have again two set squares of what 45 degrees, 90 degrees. So by using these you can draw a quadrilateral which is a square, students. What it is? Square. So just observe the properties of the rectangle and the square. Measure the lengths and measure the angles. Here also measure the lengths and measure the angles. So this is the first thing, this is the second thing, this is the third thing. So what is thing is, if you place the pair of 30 degree set squares in different positions, so same if you using this 30 degrees, 60 degrees, 90 degrees, you can again construct a parallelogram also, parallelogram also, students. Okay, which looks like this. So in this case also find the measure of the lengths and measure the angles. Okay, students. Next thing is, by using say 30 degrees, 60 degrees, 90 degrees set squares, you can form rhombus also. In this case also just measure the lengths, measure the angles. Okay, students. So using those you can also find you can also build the trapezium also. So basically in the trapezium what happens, the trapezium, pair of two opposite sides are equal. We know. So these two are the opposite sides equal, and these two are the opposite sides equal. Sides are equal. So this is about what, friends? This is about trapezium, and this is about rhombus. So in the rhombus what happens? You will know that there will be 90 degrees angle at this center, and these sides are parallel. In the parallelogram also you will have two parallel sides. In the square all sides are equal, all angles are equal, and all angles are 90 degrees, all sides length are equal. In the case of rectangle you will have two pair of parallel lines, and all the angles are 90 degrees. So this is all about the quadrilateral, students. Okay, a basic thing is you have to measure the angles in the quadrilaterals. You know, you have protractor now. By using it you can measure and observe, write down the things what we are having. So that is the thing about the quadrilateral, students. Next thing is we are going to learn about polygons. So we know that polygons with three sides is polygons with three sides is what? That is triangle. Polygons with four sides is what? That is quadrilateral, rectangle, like that. So we are having this type of if a polygon is with three sides, we are having triangle. It looks like this. If a quadrilateral is, if a polygon is four sides, it is a quadrilateral. It looks like this. So if you have polygon with five sides, it is a pentagon. It looks like this. If a polygon is six sides, it is the hexagon. It looks like this. So if it has 8 sides, it is octagon, like this. So these are the different shapes we will observe in our surroundings. So these all types of shapes are very familiar to us. We will see all these shapes in every hour in our day-to-day life. For example, windows, doors, walls, almirahs, blackboards, notebooks. So all these are the commonly rectangular in shapes. Floor tiles are rectangles. We know that triangles. So study nature of triangle makes it the most useful shape in engineering construction. So triangle, so its study nature is most helpful in engineering construction. Suppose this is the triangle finds application in construction. So basically in the construction, if you see there are the triangle shape, no, so in the constructions, railway tracks, railway bridges, so these triangles are constructed. So we will see triangles, quadrilaterals, pentagons, hexagons, octagons, all these different types of shapes in our day-to-day life. There are many applications for it, students. You know honeybees, so they will make their buildings in the hexagonal shape. What is the shape? Sorry, there is no octagon. Hexagonal shapes like this. So these are the shapes we are having in our surroundings. We are very familiar with that shapes. Okay, students, different type of shapes. So in the shapes we learn how to measure the length. We learn how to measure the angle also. Okay, students, basing on the angle and length of the sides, we have differentiated some of the triangles, quadrilaterals like that, students. So that is all about the polygons. Next thing is about the three-dimensional shapes. So until now what we have discussed is, we have discussed about two-dimensional shapes. We are now going to discuss about the different shapes, that is three-dimensional shapes. Just observe these things. So this is a ball, football, so which is the shape of spear, and this is the ice cream. So we know cone ice cream, we are loves it, so it is in the shape of cone shape. So this can, that is done up or anything, can or tin, we call that is in the shape of cylinder. So this is a three-dimensional object. So cone, it is a three-dimensional object. Spear, it is a three-dimensional shape, and this is a cube, this is a dino, it is a cube shape, it is also three-dimensional. So the box is cuboid, it is also three-dimensional. So this is the shape of pyramid, so this is in the shape of pyramid shape. So all these are the three-dimensional shapes, students. So in the case of three-dimensional shapes, we are having some notations or the some things we have to find, remember or learn. That is faces, next thing is edges, next thing is vertices. But in the case of a sphere, there are no faces, there are no edges, there are vertices in the case of a sphere. Okay, students, in the case of a sphere there will be no faces, no edges, no vertices. But in some other three-dimensional spaces, you can observe the faces, edges and vertices. Suppose for example take the cube. What it is, the students? Take the cube. So what happens? Take a die, you know that die has six faces. So this top flat surface we call as a face, and this surface, flat surface, we call as a face. For example, so this is a cuboid. Now cuboid, this is also three-dimensional, not two-dimensional. So this we call, this flat surface we call as one face. This is another face. So this is another face, and this is another face, flat surface, and this is another face, and this is another face. So all these flat surfaces, all these plane surfaces we called as the faces, students. So for a cube, the flat surface we call it as the face. So what are edges for it? So what are edges? So basically this is a face and this is a face, this is also a face. So these two faces are joined by this line segment. So this line segment from here to here we call it as edges. So this is also called as edge, this is all called as edge. So we call that as the edge, students. What it is? Edge. And what is the vertex? So vertex is nothing but, so suppose this point is called vertex. So there is one edge, there is second edge, there is third edge. So where the point where the three edges will coincide or intersect is called the vertex. Okay, students, the plural for vertex is vertices. Okay, students, so basically So what is edge means? Two faces meet at a line segment. We call that line segment as a edge. So what are the two faces here? So this is the one face and this is the another face. So this is the one face and this is the another face. So this face and this face are meeting at this line segment. So we call this line segment as the edge, students. Okay, that is about the edge. We know the flat surface as the face. And what are the vertices? So three edges meet at a point. So we call that point as the vertex. Point called vertex. So three edges will meet. So this is one edge. Oh, wait, students. This is one edge. This is another edge. This is another edge. So these three edges will meet at this point. We call that point as vertex. So this point is also another vertex. This is also 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 vertex. So for a cube, there will be 8 vertexes. So the plural form for vertex is vertices. What it is? It is the plural form vertices. Vertex is the singular form. Okay, students. So how many edges are there? So this is the one edge. This is the second edge. This is the third edge. This is the fourth edge. This is the fifth edge. This is the sixth edge. This is the seventh edge. And 8th edge, 9th edge, 10th, 11th, 12th. So basically 12. So in a cube, what happens? There are 6 faces. There are 12 edges. And there are 8 vertices. So vertices is the plural form, students. So this is the thing. So now just observe the prism. So prism, so it is a rectangular shape. This side is also rectangular shape and bottom is also rectangular shape. This side is triangular shape and the another thing is triangular shape. So for 3-dimensional prism, it has a rectangular shape. We call this as the face, and it has 3 rectangular faces and 3 rectangular faces and 2 triangular faces. Okay, students. So the triangular face, we call triangular face is also as its base. We call this triangular face as its base, students. So finally, a prism has 2 identical bases. So that base is called as the triangular shape, students. That is the case about prism, students. Okay. So again, for now I am going to writing about the prism also. Prism. It has how many faces? 3 rectangular faces. 3 rectangular plus 2 triangular. That is equal to 5 faces. 5 faces. How many edges? 1, 2, 3, again 4, 5, 6, 7, 8, 9. Almost this is a rectangle ground side, and 4 plus 5, 6, 7, 8, 9. 9. That's it, students. So it is having 9 edges. On how many vertices? 1, 2, 3, 4, 5. There will be another thing. So total 6 vertices. So this is the case about prism, students. Okay. Prism's base is a triangular face. Okay, students. If the prism has a rectangular base, so for the prism it has triangular base. If the prism has a rectangular base, then we call it as a rectangular prism. Okay, students. So a pyramid is a shape with a single base. The other faces are triangles. So for the case of pyramid, there will be only single base and other faces are triangles. So here is a square. This is a square pyramid, students. Its base is a square. So can you imagine a triangular pyramid? Can you imagine a triangular pyramid? attempt to draw a rough sketch, students. So this is the what, this is a cylinder shape, so it does not have edges, it does not have vertices, it does not have faces, so it is a cone shape, it is a sphere shape. Okay, students. So the cylinder has two bases. Okay, students, and the cone has one base. So that's it, students. That is all about the three-dimensional space. So finally, our chapter is completed, students. Chapter completed. Hello, students. Now we are going to discuss the summary of this chapter, understanding elementary shapes. So first thing is measuring line segments. We know what are line segments and lines is. So measurement of line segment is called length. Okay, students. So by observation we can compare two line segments, but it is not the good method. So by tracing also we can compare two line segments, it is also not good method. By using ruler also we can compare two line segments, so it also has some errors. But by using the divider you can get some more precious reading about the measuring the length of a line segment, students. So that is about measuring length of a line segment. Next thing is about angles. So there is a right angle, so which is 90 degrees, and there is a straight angle which is 180 degrees, and there is a complete angle. Suppose if you move in the clockwise direction and if you reach your original position after rotating, so that is called complete angle. So this is a right angle, this is a straight angle, so this is the complete angle, one revolution. Complete angle is one revolution, students. Okay. Next thing is about acute angle, obtuse angle. Suppose if the angle is less than a right angle, we call it as the acute angle. Suppose if the angle is greater than right angle, we call it as the obtuse angle. Suppose if the angle is greater than straight angle, we call it as reflex angle. So measure of angles. So how we will measure? Basically we will measure line segments in terms of lengths. The measure of line segments is length. The measure of angles is degree measure. We will measure it in degrees, how many degrees it is there. So one complete revolution is having 360 equal parts. Each part we call as 1 degree. So finally one complete angle is equal to, or the one complete revolution is equal to 360 degrees. That straight angle has 180 degrees and right angle has 90 degrees, students. So using a protractor we can precisely find out the angles. Precisely we can find the measure the angles, students. Okay, that is about angles. Then what are perpendicular lines? Suppose if there is a 90 degrees angle between two lines, we call those lines as the perpendicular lines. Suppose if there is a line segment and there is a line which is perpendicular to the line segment, and that line is bisecting the line segment at the midpoint of the line segment, we call that line as the perpendicular bisector of the line segment, students. Perpendicular bisector means it must bisect the line segment at the middle point, and it always be perpendicular to the line segment. So next thing is about triangles, students. Triangles have 3 sides and 3 angles, students. Okay. So based on the sides, we have 3 types of triangles. So scalene triangle, which means which has 3 unequal sides. Isosceles triangle, which has 2 equal sides. Equilateral triangle, which has 3 equal sides. Okay, students. Next, based on the angles, triangles are classified into 3 types. So if the angle is less than 90 degrees, acute angle triangle. If the angle is equal to 90 degrees, right angle triangle. If the angle is greater than 90 degrees, obtuse angle triangle, students. So next thing is about quadrilateral, students. Quadrilateral is a polygon with 4 sides. It has 4 sides, 4 angles, 2 diagonals, students. So if you rectangle is one type of a quadrilateral in which all the angles are 90 degrees. Square is a one type of quadrilateral. All angles are 90 degrees. All sides are equal. Parallelogram, in this there are 2 pair of parallel sides. Rhombus, it also have 2 pair of parallel sides, and diagonals are equal, like that, students. Next thing is trapezium. It has pair of 2 opposite sides are equal, students. Like that, these are the quadrilaterals. Next thing is about polygons. So polygons are nothing but polygons with 3 sides is triangle, polygons with 4 sides is quadrilateral, polygons with 5 sides is pentagon, polygons with 6 sides is hexagon, polygons with 8 sides is octagon, students. Okay, next thing is the 3-dimensional shapes. So these are the some of the 3-dimensional shapes, students. So considering the cube, it has faces, edges and vertices. Face is a flat surfaces. Cube has a 6 faces. Edge is the 2 faces meet at a line segment. That line segment is edge. So cube has 12 edges and vertices. So 3 edges meet at a point called vertex. The plural of vertex is vertices. That cube has 8 vertices. And the case of prism, so in the case of prism, there is a triangular. If the base is triangular, then we call it as the triangular prism. So there it is having 2 identical bases for prism, students. So it has finally 5 faces. 3 are rectangular faces, 2 are triangular faces, 9 edges and 6 vertices, students. So for the case of cylinder or the sphere or cone, there will be no edges, no vertices, no faces, students. Okay, that is the thing, students. Our chapter is completed. Our summary is also completed, students. So have a nice day. Keep smiling. Don't forget to subscribe Sreenath Academy for more videos on all chapters, all subjects from class 6 to class 12. Have a nice day. Keep smiling. Bye bye.